So this is our today's topic for this session. So we will discuss about auth, what is the auth types, what are some terms that is using in auth 2.0, and we will also see some misconfiguration. Okay, next slide. So this is a brief about me. So right now I'm working in Infosys as a VM associate, and here I'm Twitter and LinkedIn handle. Next slide. So before going to auth, let's first discuss what is authentication and authorization. So anyone here want to see about authentication and authorization? You can raise your hand. Anyone? Okay, no problem. So this is the basic definition of authentication and authorization. So here, as you can see in this diagram, so authentication defines who you are. It will give you identity like your address, your name, your number. So this will be your authentication. And authorization means what type of access you have in that particular application. So as you can see here, so this is the authorization, like what you can allow to do in that particular application. I hope it will be clear to you. Next slide. So we will look for some ways of authentication. So basically we will look for simple login, then single sign-on, then there will be a magic link, and also we will discuss what is delegated authorization. Next slide. So this is the simple login page. So as you can see, here is a username and password field. So we have to put, firstly we will put our username and password. It will go to database. It will generate the hash for it. After generating and verifying the hash, if it is correct, we are able to log in into that application. So this is the basic flow of login page. But it contains some downside also. So the downside, it is not user friendly and it requires many maintenance. So it is high maintenance. So that's why new way of authentication also comes in. Next slide. So there is a single sign-on. So what does single sign-on means? So I can take an example. So let's say there is a organization and they want to put every application in one dashboard. Then they can use single sign-on. So what will happen there? They have to authenticate themselves once, then they can access whole the application. So as in this diagram, here is the user. So user is asking service provider to authenticate. Then service provider is redirecting it to identity provider. So identity provider would be Active Directory, any ways of authentication. Then after verifying the credential that we put in identity provider, it will go to service provider again, and we are able to access all the application in one dashboard. So let's discuss why we need auth. So before discussing, I just have a question for you. So here, as you can see in this below diagram, we PUBG is asking to access your Facebook username and Facebook password. So anyone here play PUBG? Can you raise your hand if you ever play PUBG? So would you give your name, like direct Facebook username, Facebook password? Anyone? Okay, so you should not do this. You will see the reason after this. Next slide. So here you should not do this because you are not allowing only the friend, like you are not defining the set. You are giving your Facebook whole access. So this will be a risk. So you should not do this. So that's when auth comes in. So we will discuss now auth. Next slide. So that's why auth is here. So anyone here familiar with auth? Yeah, did you ever use auth in your daily life? Can you give me example? So how auth looks like? Any idea? Okay, next slide. So this is the basic login page. So you ever connect with this, continue with Facebook, continue with Google. So you use auth, but you are not aware that that is auth. So you have used this page once in your till now. So this is auth. So this is the delegated authorization. So in our previous example, as we are asking Facebook username and password, but what's happening in auth is we are integrating Facebook and we are asking connect with Facebook and we are redirecting it to Facebook server. So you are putting your credential on Facebook only. So this way we are not sharing the password directly, we are using access token to authenticate ourselves in the application, that is PUBG. I hope it will be clear to you. Next slide. So now what is auth? So auth generally means open authorization. It's an open source protocol. Here what we are integrating third party application to use them. You can see in real life application also that there is a feature. You can connect with Facebook, you can sign in with Google, you can sign in with Twitter. So this is the basic example of auth 2.0, and here we are using access token to authenticate ourselves in the application. So here in this diagram, auth 1.0 is there, but it is depreciated because of some misconfiguration. It requires signature in every header. So, and there are some there are the RFC for auth 1.0. You can refer that also. And now comes to auth 2.0. We will discuss auth 2.0 in further slides. And here is the RFC for same. And in auth 2.0 we will discuss its grant types, what some misconfiguration happens, and what are the common vulnerabilities that found by security researcher. And there is one more version that is in draft, that is auth 2.1. Next slide. So before discussing auth 2.0, let me clear first thing that auth 2.0 is primarily built for authorization, but sometimes developer use it for authentication also. But there are some extension that is known as OpenID Connect that you can use for authentication. It will give you ID token that contains your username, password, that contains your name, email ID, phone number as your identity. And in auth 2.0, it will generate the access token that contains what kind of access you have, what particular permission you have on that application. So this is the basic diagram. So any doubts till now? Okay. So now understand some terms that we will use in further slides regarding auth 2.0. So there you see a resource owner. Resource owner is the simple user, end user we can say, and the redirect URL will be the return path where authorization server redirect to us. So this will be a redirect URL, and the client application will be the application that we want to use. And the client ID will be the associated ID with that particular client application. And here is the authorization key code that we will discuss, that you will have a better idea in further slides, but you can think it as a temporary code to get the access token. Then there is a client secret. So this is not the public, this is confidential data. So client application is stored this secret in some place. So you have to use this securely. That is client secret. Next slide. So this is the auth server, authorization server. So as we took example previously, PUBG 1. So if you relate to it, so Facebook will be our authorization server in this case, and we are accessing our friend list. Then it will be a resource server that we are calling to get our friend list. An access token will work as a password for you to authenticate. And this response type defines the what kind of data you want. You want code, token, and it sometimes defines the flows also, grant types also. And there is a consent. So you got this page while logging into some third-party application that you want to allow this, you want to deny this. So this is the basic content that user will provide. And then this is the scope. So if we discuss, if we take the example of PUBG only, so in PUBG, what we are allowing, we are only allowing them to get the access to the friend, their number. So this will define the scope, that they want read data, they can create the data, yeah, they can delete the data. So it will be a basic scope. There are some more parameter, that is state. So state will use as a CSRF token. Okay, so front channel and back channel. So this thing we will see in our grant flow. So what's happening in front channel is we are directly accessing the our application, putting everything in the bar, and we are getting data. So this is the basic example of front channel, but it is less secure because anyone can intercept this. And back channel, it's server to server communication. So here all communication is going into backend, so it is a back channel. So this thing, this is a basic overflow. We will discuss more about the grant types in different slides. So here what's happening is resource owner is asking for a authorization request to the client application. Then resource owner grant this authorization. Then client application will go to the authorization server, auth server, to get the particular access. Then authorization server will send the access token, and then with the help of access token, it will get the requested resource from the resource server. And in this way, this whole flow works. So here we will see OAuth 2.0 grant types. So OAuth 2.0 grant types, sometimes also known as flow types. So here our main goal is to get the access token and use it to get the requested data from the server. So here I take a simple example, so it will be more clear to you. So let's say you visit a hotel, any place, then the person is providing you an access key. Then you are using that access key to unlock your room. So this is the basic flow that you also see in your real life. So that's way, in the same way, the person who is providing you access key will be the authorization server. An access key will work as an access token, and with the help of that access key, you are able to unlock this thing, so it will be a resource API. So now we will discuss about grant types. In this particular session, we will discuss 5 authorization grant flow. So we will see. So first one is authorization code flow. So it is mainly used for web application, native clients and desktops, where we can securely store our client secret. Next slide. So here I will take this example and explain you in real world language, so it will be clear to you. So let's say you are going to PUBG and asking to connect with Facebook. So you are going to PUBG, then PUBG will redirect to authorization server. In our case, it will be a Facebook. So after checking our client ID, state parameter and path, so it will redirect us to with the help of authorization code that I say as a temporary code in previous slide. And with this help of authorization code, client application use their secret to prove that yes, I am the only one who is asking for this data. Then it will go to authorization server. Authorization server check this authorization, check the client secret, then it will give the access token. And with the help of that access token, it will get the requested data from the resource server. So here if you see, the color will differ. So here in the blue color, that means every communication is going into front channel. But here we are getting access token from authorization server to client server. So that is the back communication, back channel communication. So I just break down the steps for you. So as I mentioned earlier, we are connecting with Facebook. Then the Facebook will redirect us to the website.com. Then with the help of redirect URL parameter and response type, like what type of response we want from the server. Then it will redirect to login page where we have to authenticate ourselves and give our consent. Then it will give us the basic temporary code with the help of state parameter. So there will be a less chance of CSRF. So after getting the authorization code, we will use that authorization code with the client secret. So as you can see in the left hand side screenshot, there is a grant type. I defined the grant type with the help of code and the redirect URL, and also with the client ID and secret to prove that yes, I am the client that was requesting the data. Then with this, we got the access token with expiry and what type of token it is using. Then we send this token an authorization header with in form of bearer token and we get the requested data from resource API. So any question till now? Anyone? Okay. So there is one more extension that is using for authorization code flow. So it will reduce the chances of leakage of the authorization code. So this is the PKCE. So proof key code exchange is an extension that will generate the code challenge, and it will verify that code verifier. After getting, we get the authorization code and access token. So it will reduce the chances of authorization code interception attack. So this is the basic picture that we discussed earlier. So here we are asking for the client, but here in this case we are like client is generating code challenge for us. Then it is going to authorization server with the help of code challenge, and then authorization server will redirect us to login prompt, then where we have to put our like credential and consent. Then after that it will redirect to our mentioned redirect path, return path. Then with the help of code verifier and authorization code, we get a token, and we use this token to get the requested data and send it in form of authorization header. Then there is one more flow, that is implicit flow. So implicit flow is like it's not that secure, because there we can't store the client secret. It is for single page application, pure JavaScript app that is using. So same thing we are doing here also, but we are not getting the temporary code. We are directly getting the access token. Next slide. So here in the resource owner, like we are going to the application, asking for the request. It will check the request, then it will redirect us to login page. There we have to put our username and password. Then it will directly give the access token. It will not check who is the user or who is the client application. And we are able to log in, we are able to get the data. And the whole communication is going in front channel. So it is not that much secure. There are some downside. As I mentioned earlier also, there is no back channel needed in implicit flow. And redirect parameter, like we are getting directly access token in the URL in form of URL fragment. So anyone can use this access token to get the data. So it is not recommended. So moving towards client credential flow. So here every communication is going into server to server, machine to machine. Let's say I will take a real life example. So let's say you want your printer to get the requested data from resource API. So what you will do here is you will put your username and password, then you will ask authorization server to verify it. It will be more clear with the diagram. So here like you are putting your client ID and secret to the authorization server to get the access to token. It will validate the client ID and secret, then it will generate the access token for you. Whole communication is in back channel. So it will be better, and it will depend on what kind of, for what purpose you are using it. So it will differ on basis of our requirements. Next slide. So there is a resource owner password code. So like in this particular thing, what we are doing here is like we are putting our username and password by trusting the application. And here like this is not the authorization, like this is the opposite of auth flow, but it plays a role. Like let's say if you want to authenticate directly to application, I can take a simple example of Google. So you are putting your Google mail ID and password directly to a Google and getting access to the all application like Drive, Google Documents, photos, everything. So that will be the example of it. Here you are directly putting username and password. It will validate with the authorization server. Then server will give you access token. Next slide. So it will more clear with this picture also. So you are going to the application. Application will directly redirect you to the login prompt. Then you have to put your username and password. Then authorization server validate that. Then you got the access token directly on the redirect path. And in this way you can access the data. So this is the like summary of what we discussed till now. So here authorization code requires front end also, back end also, user interaction is also needed, and it can store the client secret. But whereas implicit grant doesn't need back end, its communication is in single page application, so it's need only front end, and it doesn't store the secret. As I mentioned in the downside of the implicit grant, and the client credential, it doesn't require front end because every communication is back to back channel, so it doesn't require front end, and it doesn't require user interaction because server is communicating with server, so there is no user interaction. And password grant, we require everything. So this will be the question for you guys, you should speak. So let's start. So can you store a client secret in a secure place? So what will be the case if you are not able to store the client secret? So anyone have want to give the answer? It is written there. Okay, no problem. So it is implicit grant, and if it is yes, then it will go further. So as your client is a web application, so no, then it will be a client server credential. As we mentioned, every communication is going into server to server. Then do you trust the credential directly to put into application? If yes, then it will be a resource password based grant, otherwise it will be a authorization code grant. Hope you understand the concept. Next slide. So now we will discuss about the misconfiguration that happens in OAuth 2.0. So let's say if we are able to use authorization code more than once, we can use authorization code twice. So it will not the good thing for the auth implementation. So we should take care of this. Then access token in the URL. So here what is happening is we are directly giving the access token in the URL browser in form of URL fragment. So this is not the safe way, and it is not recommended to do this. And there is an insecure storage of secret. So if your client application is not able to store the secret in a proper way, then it will create a risk. So as an example, if your mobile application is storing the secret in a simple device, so it will not be a good way. And if your server is storing the data in form of config files, in form of any other sensitive files, and if you are disclosing, exposing the client secret directly into the code, then it will create a risk for you. Anyone can use your access token and access the data on behalf of you. So CSRF token fixation. As I mentioned earlier also, state parameter is used for CSRF, is used as a CSRF token. If a state parameter is not validating, then anyone can use it to perform the CSRF, and if they are able to perform the CSRF, they get the state parameter in form through XSS through other way, then it will be a lifetime CSRF. So it will be a bad thing. So you should validate a state parameter. Authorization code leakage via referral header. So if you ever browse any website, so you will see there is a add link. You are able to get the FAQ. If you are clicking on that link and you are not sure that what this particular page is, so you are redirecting your browser to the malicious page, and in this way you can leak your access token and authorization code. So now we will discuss some attack narrative that found by some security researcher. So here is code stealing via open redirect. So here in redirect URL parameter that I highlighted. So in this particular example, company.com, all subdomain can be used for company.com. Then we are using example.company.com, and we are redirecting it to the server. So redirect URL is not validating here, and we are able to redirect our server to the mentioned path, and in this way we are leaking the authorization code. And here is the attached report also. Then CSRF. So state parameter will be the key for the CSRF. If you are not validating your CSRF, then you are asking anyone to give you use it as a form of CSRF attack. So here always remember to verify the state parameter while implementing OAuth 2.0. So here state parameter is not resuming, so we are giving random value, and we are able to get the access token in this particular screenshot. So you can see, and you can find the same write-up for it. Then cross-site scripting. So here we are putting our accesses payload in the redirect URL, and what we are saying it to click on this link, and it will give you a whole document.domain, like your domain name. So if you are not validating this redirect URL parameter, you are asking, like, you are redirecting to this link and giving your domain name through accesses. So this will be a one scenario for accesses, and here is the attached report. Then open redirect bypass. So let's say some company use whitelisting techniques to allow some domains, but they are not checking that someone do their subdomain takeover, and someone use the same subdomain. So if we are able to get the same domain name, then we can impersonate, we can pretend them as a legitimate client, and we can use this to get the access token. So this is the CVID, that is like it is a recent attack that happens on Expo framework. So this is vulnerable with auth. So what happened there is, next slide. So here is the link. Attacker send the link. User click on that link. It will redirect it to expo.io page. Then there they are setting it to some attacker website. Like return URL is setting to some attack parameter, attacker website. Then it is going to Facebook, asking for a token. Then Facebook redirect them to the redirect path with the token, and attacker can use this token to get the access. So these are some suggestion for developers and hacker to look for OAuth 2.0. So developers should validate state parameter and redirect URL parameter to prevent the CSRF attack and to prevent some common attacks. And always remember to use the exact string for the redirect URL parameter, so no one can use open redirection to get the access token. And always remember that authorization server properly implement the injection mitigations. And always set the scopes that will define what type of access you are allowing a client application. And for hackers, so always look for the pattern. You can see if a star is there, you can use any subdomain to get the access. You are able to get the open redirect, and always not assume that proper mitigation is there. There are some factors that can make them vulnerable. So you should look for the ways, and always try to do CSRF bypass on the state parameter. Let's say if a state parameter is not validating, you can use state parameter once then twice. If you remove state parameter, server is not giving you an access. So you should try all the CSRF bypass on the state parameter.